All right. It would appear at this point in time that many in this civil engineering program are through the fact of having learned geometry with your right hand coordinate system in engineering and in math, and with your left hand coordinate system in survey and perhaps military and mapping. So now let's see how we can bring them all together. And bringing them all together is not too bad if you just switch out from the fact that very often that you're going to look at things here as northing, easting, and I'll just go with Z here, and here you're going to think of them as X and Y and Z, based on an assumed, in this case, an assumed standard position angle of essentially quote-unquote east, and here based on a standard position angle of north. Now if you go way back, at least in the everyday math curriculum, you will learn that at some point you'll learn to draft your circle graphs. Let's say you had something that was 1/8 of a circle. You would have filled it in like this perhaps. So you learn to graph with your left hand. Left hand meaning that your fingers went up the north and this was a positive turn. But you learn to do your angles with your right hand, that you would look at this as a positive angle that way. So how do you make this shift? Well, you make this shift pretty easily, realizing that you're going to do all your points. Do an edit undo here. You're going to do all your points by stacked northings, eastings, Z's with the one chaser out at Rusty's. So we'll go 1 dot 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 northing the nth, northing the nth, easting, and the nth Z with 1 there. And then you're going to put your angles here. Your transformation matrix is going to be also your change in northing here, your change in easting, your change in Z with your 1 here. And then as we remembered before, we'll go ahead and make this 1 0 0 0 1 0 0 0 1, and of course 0 0 0 here along the bottom. And we're going to remember that the first row and the first column is going to be northing. The second row and the second column is going to be easting. And the third row and the third column is going to be Z. Whereas over here, on the right-hand coordinate system, you're going to go ahead and you're going to stack your points by X, Y, and Z with a 1 chaser. Of course, the first through the dot dot dot, X to the nth N, the Y, the nth Y, and the nth Z, and of course 1 is just the same all the way across. And once again here, when you do, you're going to have your transformation matrix. It's going to be your delta X, your delta Y, and your delta Z, and the 1 chaser. Once again, 1 0 0 0 0 0 1 0 and 0 0 1, and of course along here we have zeros along the bottom, and where they have the first row and the first column being the X, the second column and the second row being the Y, and the third column and the third row being the Z. What you're going to need to know finally is that you, on this side, you use the right hand rule, and on this hand side you use the left hand rule. Now that's just best demonstrated in general, but we'll talk about at least it here on the odd one, that you should use your left hand for calculating and thinking about turns here, and your right hand here, which means, of course, that counterclockwise is positive, and in this case, clockwise is positive. But you also, as I finally fill this out, you want to deal with the fact that to get a positive turn, you put your right thumb along the axis of spin, along the axis, not of evil, but the axis of spin. And on this one, you put your left thumb along the axis of spin. And then your fingers are showing what a positive turn is. So let me go ahead and let's see if we can move down here. I guess we can do, we got a little space down here in the bottom. Which means when you use those angles here, a transformation, for instance, if you want to, let's say you're going to turn about the northing axis. (15 degrees). Well, of course, these stay the same, 0, 0, 0, 1, and of course these are 0, 0, 0. You're turning about the northing axis, so you end up locking these, right? You've locked up the northing axis, and so if you're turning 15 degrees, remember the code, or not the code, but the angle of the group is cosine minus sine, sine, cosine, except for the middle one. In this case, the cosine of 15 degrees is 0.9659. The sine of 15 degrees is 0.2588. It's minus 0.2588. This is 0.2588 and 0.9659. So you get the sense that here, and if you're turning that same 15 degrees this way, about the same northing, you wouldn't put it there, but you would put it this way. Of course, again, 0, 0, 0, 1, 0, 0, 0. In this case, you're spinning about that northing axis. You were spinning about the northing. In this case, you'd be spinning about the, would be the y-axis. So you would have this 0, 0, 0, 1, and you'd fill these in here, here, here. Let me think. 0, 0, 1, 0. Oh, we're going to do this wrong. 1, 0, 0, 0, 1, 0, 0, 0, 1. And so this, of course, would be, the values would be switching in right here. So, but in this case, it would be a positive turn. In this case, it would be a negative turn. So you're going to see that by making sure that you do, with the left-hand coordinate system, things in terms of northing, easting, z, and with the right-hand coordinate system, x, y, z, everything else turns out to be exactly the same and correct. So you do not have to learn things differently, and you can even massage your calculator so we can do that. And if you stay within the coordinate system, left or right hand, until you work the end of a problem or a subproblem, you will be empowered by this. When you get towards working in 3D, whether it is learning how to control the blade in a machine control, or just learning how to control your robot, or just learning how to deal with gaming and 3D spatial work projected onto a 2D plane. All right, so that's a bunch there. The first time through, 10 minutes post Wizard of Oz, and running up to the fact where mostly what we're looking at here, and now I'm going to finally go ahead and push this out, is also this value. We're going to continue to look at how these, not only the basic math, but also the programs start to work out. So I'm going to always end up doing this in the short term. We're going to export a layer image, and we're going to put it in junk for now, so we don't have to type anything in. We're going to hit save here. We're going to replace it, yes. Close that out, no. Go immediately to SketchUp 8. No, we don't need to. You can go to Max 3ds, start using SketchUp. We're going to go ahead and bring that in, because if you noticed, when we're doing this, and the program is called, what's it called again? It's whatever Sal uses. It is Smooth Draw. So we're going to go ahead and do this. File. We're going to import. And we're going to get pretty good. There he is. Junk PNG as an image. Looks good to me. Open. Put it here. You notice there it didn't bring it in as, in this case, it did not bring it in because I had not done it on the background image. It did not bring it in as background. So we're going to go ahead and still learn to push that up. Get very good at doing this. Whoa, so hard. I'm working with a pen here. That concept of grabbing, rotating, holding the shift key from here to here and bringing it up. And now you have that general sense of how quickly you can learn to bring things and play around with them within SketchUp. But of course, what I was hoping for was that kind of Intel type commercial where this would actually be transparent, so that you don't get, as I go back to here and go back to there, you do not get that out of what we just did. So remember, left hand for left hand, right hand for left hand, and stay consistent. There's only one person that I know of that can work and describe a right hand coordinate system with his left hand, and he's special. Thanks for listening.